Hello everyone, myself Mrs. Janvi Darshan Raut, lecturer in Electronics and Telecommunication Department of Pravin Patel College of Diploma Engineering and Technology. In this video, we are going to study our practical number 8, that is use PID controller to control temperature of given process. What is the meaning of PID? That is, first is the proportional, integral and derivative controller. So PID means combination of these three controllers. PID controller improves transient response as well as offset of system without affecting steady state. PID controllers are used in process control applications. At initial condition to bear the system process should be delayed by few seconds. For that, PID control has significant role in practical. This practical will help the students to develop the use of PID controller. The relevant affected domain is demonstrate working, maintenance of tools and equipments. Now, minimum theoretical background. Students have to know the derivations of individual, proportional, integral and derivative controllers as well as the combination of PID controllers. The controller in the forward path, which changes the controller input to the proportional plus derivative of error signal, is called PD controller. The expression for that is P of t is equal to Ke of t plus Ki integration E of t dt plus Td derivative of E of t dt, where P of t is the output with proportional and derivative, E of t is error signal, Kp is proportional constant, Kd is derivative constant and Ki is integral constant. The aim of PID controller is to increase the stability of system by improving control, since it has an ability to predict the future error of the system response. In order to avoid effects of this sudden change in the value of error signal, the derivative is taken from the output response of the system variable instead of error signal. Therefore, D mode is designed to be proportional to the change of the output variable. To prevent these sudden changes, I control is used for remove the offset. Now, practical setup, or you can say circuit diagram, is as shown in this video. Is they are having a comparator, or you can say error detector, then the three process controllers Kp, proportional, Ki, integral, Kd is derivative, and this process plant. Now, resources required can be PID controller setup, temperature sensor and digital multimeter. Precautions to be followed: ensure proper earthing to the equipment, ensure the power switch is in off condition, ensure that the power supply switch is in off condition. Procedure for PID controller is connect given PID setup to supply as shown in the figure. Connect RTD to the given PID setup. Set the reference temperature as per available setup. Set the error input value as per the available setup. Set derivative control port to minimum position. Set integral control port to minimum position. Calibrate the PID controller as given in manual. So, given setup. Switch on the heater on the board. Measure the changes in temperature corresponding voltage for each 1 second delay only with proportional and then proportional with integral. Measure the change in temperature and corresponding voltage for each 1 second delay only with proportional and derivative with integral controller. tabulate all the readings and plot the graph. So here is the calculation, or you can say the calculation tables are given to write the readings. Students must have to solve any two questions from this given practical related questions. Thank you.